You ever stop and think about how the apps on your phone, these incredibly complex pieces of software, actually get made? It's definitely not just some lone genius hammering away at a keyboard in a dark room. Nope. Behind every great piece of software is a massive, coordinated effort, and most importantly, a plan. A blueprint, if you will. And in this explainer, we're going to break down that blueprint for code.
I mean, think about it like this. You wouldn't build a skyscraper without a ridiculously detailed plan, right? You wouldn't just show up and start laying bricks. Well, complex software is exactly the same. You absolutely need a structured approach to manage all the chaos and get from a cool idea to a finished working product. That structure, that blueprint, that's what we call a software process.
So what is it really? Well, a software process is, pretty simply, a structured set of activities you need to do to develop a software system. Think of it like a recipe. It lays out the ingredients you're going to need and the exact steps to follow to bake the cake, or, in our case, to build some awesome software.
Okay, so here's our game plan for today. We're going to start with the absolute fundamentals, the stuff that's common to all software creation. Then we'll dig into the two big philosophies, planning everything out at the start versus being flexible and agile. We'll see how those ideas play out in three classic models: Waterfall, Incremental, and Reuse. And you're going to want to stick around, because the final takeaway might not be what you think.
All right, let's dive right in with the basics. What are the core parts, the fundamental activities that make up any software process, no matter how different they might seem on the surface? Well, it turns out pretty much every software project in existence boils down to these four things. First up, specification. You got to figure out what you're actually building. Then, design and implementation. Okay, let's go build the thing. Next, and this is so important, validation. Did we build the right thing? Does it do what the customer actually wants? And finally, evolution. Because let's be real, software is never truly done. It's a living thing that has to grow and adapt over time.
Now, how you organize those four activities, well, that's where things get really interesting. And it's where we see the two major philosophies in software development clash: plan-driven versus agile.
This really gets to the heart of the difference. Plan-driven on the left is like having a super detailed roadmap before you even start your car. You plan out every single turn, every rest stop in advance. Agile, on the other hand, is more like exploring with just a compass and a general destination in mind. You planned in short bursts, which makes it way easier to change course when you find a better route, or when the customer changes their mind, which, they always do.
So, keeping those two big ideas in mind, let's see how they get turned into concrete models that teams use every day to actually build stuff.
We're going to dig into three really key models. We'll kick things off with the Waterfall model. That's the original plan-driven classic. Then we'll check out incremental development, which is a much more flexible approach that can be either planned or agile. And finally, we'll look at integration and configuration, which is the super pragmatic model that's all about not reinventing the wheel.
Okay, let's start with the OG, the one that really laid the foundation for decades of software engineering, the waterfall model.
And you can see exactly why they call it waterfall, right? Progress flows in only one direction, just like water cascading down a cliff. You have to finalize all of your requirements before you even think about design. You lock in that design before you write a single line of code. Each stage has to be 100% complete before the next one can begin. There is no going back upstream. And right there, that's the model's Achilles heel. It's rigidity. Just imagine you're halfway through building and the customer calls and says, "Hey, you know that huge feature we talked about? Yeah, we want to change it." With Waterfall, that's a complete nightmare. It is incredibly expensive and difficult to go back and change something. This model basically freezes your plan in carbonite, which is great if you're 100% sure about everything from day one. And, how often does that actually happen?
So, as a reaction to that inflexibility, a whole new way of thinking started to pop up. Let's take a look at a much more flexible approach, the incremental model.
So instead of trying to build the entire system all at once, the incremental model is all about building and delivering it piece by piece in increments. And this has some huge advantages. First, the cost of making changes plummets. Second, it's so much easier to get feedback from your customer because you can actually show them a working piece of the software early and often. And that leads to the third big win. You get a useful product into the customer's hands much faster.
But, it's not a silver bullet. There's no such thing. For managers who are used to having one giant master plan, this kind of process can feel a little chaotic.
And there's a real technical risk too. As you keep bolting on new pieces, the underlying structure of the code can get messy and unstable unless you are constantly cleaning it up, a process that developers call refactoring.
All right, on to our third model, which is all about one thing: efficiency. I mean, why build something from scratch if someone else has already built a piece that does exactly what you need? That's the whole idea behind reuse and integration.
This has become a super common approach, and for very good reason. When you use pre-built components, what are often called commercial off-the-shelf or COTS systems, you slash your costs and your risks. You're basically building with puzzle pieces that have already been tested and proven to work, which means you can get your final product built way faster.
But, and there's always a but, there is a trade-off. That component you find might only do, say, 80% of what you really want, so you have to compromise on your requirements. And maybe the bigger issue is that you give up control. If the third-party company that makes your component goes out of business or just decides to stop supporting it, well, you're stuck. You have zero control over where that component goes in the future.
So we've looked at the rigid waterfall model, the flexible incremental model, and the efficient reuse model. Which one is the best? Well, turns out that's totally the wrong question to be asking.
This quote just hits the nail on the head. The reality of building software today isn't about picking a side, being Team Waterfall or Team Agile. It's about being a pragmatist. Real-world systems almost always use a hybrid approach, cherry-picking the best ideas from all of these different models. And that is the most important thing to take away from all of this. You need to think of these process models not as rigid rules, but as tools in a toolbox. There is no single best one. The right process depends completely on the project, the team, the customer, the problem you're trying to solve. So, I'll just leave you with this final thought to chew on. Knowing what you know now about the trade-offs between planning, flexibility, and efficiency, if you were going to build an app tomorrow, what would your process look like? What kind of blueprint would you draw up?